Yes,
about
sir.
that.
There you go. It's starting to
There you go.
That's what I started with here. This is actually the spool, I guess, that I was trying to use. These are really too large for what I was trying to do. You know, if you actually look at it and try to figure out what to do, most of what I have here is too large. It's if you want to turn it a quarter of a turn, then it's the distance that you move is the distance around this wheel, a quarter of a turn. So, you know, a quarter of a turn around this thing is quite big. You know, it goes way out there. But anyway, it was a string deal. It was put out by Rick Tucker, I think, talked about it one night. And I think this is what he had in mind. I'm not real sure. But it sounded like it, and it did work. You know, there wasn't anything wrong with it other than me, probably. The string goes around this thing. I went like 3 times to make sure it would hold good, and it just goes on around the jig. This was an index wheel I put on here, but there you can see how the string hooks up and to the router. One problem with this that I had is, one, this string was on the corner rather than the middle underneath the bit. And the other problem is that you know, I got several problems here. The other problem I have is the bit's too big. You see that 1-inch bit, you know, he's trying to take a chunk every time I move it. So that didn't help anything. And the other portion is that this router sled that I have is not stationary. So it can turn any direction you want to turn it. And I found that where this thing was tied up here, it made the router sled, the back end, able to move too much. I mean, it doesn't take a whole lot to make it swing. And when it swings, of course, the bit swings. And you can see where the bit, you know, swung out in different spots here. So anyway, after a couple of tries, I stopped that. I said, I'm not going to do that one. But if I did it again, and the weight, let me talk one more thing here. The weight, the string wraps around, and the weight that keeps it pulled back, keeps the router pulled back to its corner, it doesn't take a whole lot of weight. That's just a clamp, you know, one of those hand clamps that you on the string that's pulling it back. But that probably was okay. It's probably my swing and the motion of this thing. There's a better close-up of that mess I made. But anyway, there's just another one of the string. And I'm not sure this is what Rick was talking about, but I think it is. I think he's on here tonight. Maybe he can explain it.
Hi, Bob. Yeah, this is Rick. That's pretty much the idea. I like your idea of wrapping the line more than once around the spool. That's a good idea.
Yeah.
I would suggest on the router to make a clamp it somehow to your sled. And so then when you move it, the router won't move. And if you want to set the depth, good idea is just to use popsicle sticks and put them on there, how many ever you want to go deep, and then touch your tool to your piece and then pull out 1 popsicle stick, 2 popsicle sticks, however you want to go deeper. That way you don't have to make one deep cut.
Sure. I actually have a stop here. You see this piece here? That was a depth gauge that I had set up, and the router itself is tied to this. There's a little thumb screw on this side that you know connects it to this router sled that I made.
Okay.
But still, it turns. It twists too easy, you know, and it might. I don't know. I'm just guessing that it's because of where I've got it tied to the sled. It's over in the corner rather than under the router bit. But I think if I had you know, you look at some of the other guys that have made these sleds and made this type stuff, Spiral and Jigs, they've got some that actually are on rails where it slides in and out. It's not going to slide. It's not going to twist on you.
What I do is I just have on my platform, I have a rail that is clamped on to the platform so that the router can slide along it. And
Okay.
one thing you might do on it is put a couple of screws on the front of the rails so that the chips don't interfere with the depth. And so
Mhm.
you have two points that glide along that rail to keep it steady.
Yeah. Yeah, that sounds like a good idea. I like the idea of the rail. That sounds good. Keep it from trying to twist on you.
Yeah, and then also on your platform, I've seen where you can, um, without the pulley on there, you can take and make a inclined plane so that you can cut an angle just by sliding up at say 20 degrees or 45
Well,
degrees.
right. And that's what I did here. I made a platform like you're talking about that was up probably 2 or 3 inches on one end. So it was sloped and just, slid the router back and forth on that. And that worked fine. You see, those flutes came out fine with the
Yeah, that
same
looks
bit.
good.
Yeah, with the same bit, I just didn't have, I could control it better rather than letting it, swing around on me. The other thing too is with that slit, like this angle that we were talking about, where it's raised up at an angle, when the movement in the router is in the direction of the cut, whether the other way, the movement of the router is not going the same direction as the cut. So when you swing it to the side, you can see it dip out. If it's going the same direction as the cut, you're not going to see it. It's going to just go along the direction of the cut anyway. Anyway, that was my 2 cents.
And also you experiment with your router bits. You can use a 90-degree bit, and you can use the round nose bit. You can take and use a flat bottom bit, and you can even adjust your height so that the bit cuts more on one side than the other side. So there's an infinite possibility of what you can do with the router and the bits.
Use a
Right.
coving
Yeah.
bit, core box bit.
Yeah, this is a core box bit here. But the smaller bit would have been better too. I wanted a big groove, and that's about the only way I could get it was with this core box bit. But it's a 1-inch bit.
But you're
Yeah,
right,
pretty cool.
that's a lot of wood to move in one pass.
Yeah, it is. And I was trying to take shallow cuts and adjust it, but I still think it's more the angle of the cut versus the motion of the router. But anyhow, I can try it again. If I do this again, with this jig it would probably be a smaller bit, and maybe like Rick just said, put a rail up here or something here where I can't where I'm sliding along the rail and it keeps the router from trying to dip one way or the other.
Yeah, I think that'll work better for you.
Yeah. But anyway, I had fun doing it. Those other guys, I've forgotten Jeff Salter has a good jig, and so does that Barry somebody. I saw that one too. I like that.
Hey, Bob, I don't know if you can see my video here talking. So I have the same router.
Okay.
There you go.
There you
Now
go.
we're going.
Okay.
Thank you.
So I
Look at
took
the
this
gas.
aluminum plate and I put the hole in the middle of it so that I could capture, behind the chuck and the headstock. And so then I got these 5, 6, and 7-inch pulleys. And the next picture is that's behind the chuck. And then I've got a router sled that has a rail running parallel with the bed. I have a stop on the left that's clamped on. I have a stop on the right. And you can see here, scrap piece, I was playing around with cutting some diamonds. And so there's a better picture. I've got this sled And then
Rick-
I've got the aluminum clamps on it and to clamp the router to the sled.
Those are just rings. You're not using pulleys, is that correct?
Well, this is a prototype. So yes, they
Okay.
are just eyelets.
Okay, cool, thanks.
So
Very nice.
when I move the router towards the tailstock, that turns the pulley, which, you know, the lathe. And so that's how I get the spiral.
How do you keep the
One
tension?
thing that if anybody is doing this, a router on the lathe, I suggest you unplug the lathe. Because I turned the router off in between the cuts. And you go back, the first thing you want to do is turn the lathe on. And so make sure you unplug it. That will avoid that accident from happening.
How do you
And
keep
then I have an
tension?
indexer that is on the lathe. So otherwise you would probably have to have an indexer to put on it.
How do
And
you keep the
the
tension on your?
platform is in my tool post. So that's what I came up with.
What are you using for a weight?
I think I had a V block or something. It's just, I don't know, probably just a few pounds to get it to work. And since this is just a prototype, that's a shoelace, a bootlace.
Mm-hmm. Yeah, it looks good.
What are you using to tension it?
There's a weight on the back side. If I had it, if I had the pulley wide enough, I could wrap it around like Bob was talking about. But I just have a weight on the back side. And then as I move the router sled, the wheel turns and the weight comes up with the
So you
with
don't
the
want
lace.
the string to slip on there. That's what the weight's for, is to make it stick to the wood.
Right, right. Just friction
So you're
on there to
so you're moving
keep-
you're moving from the chuck towards the tailstock on the for the cut then.
Yes.
Okay.
How do you keep the
And-
depth the same on a tapered object?
Pardon
What?
me?
How do you keep the depth the same all the way down a tapered object?
Well, I just, like I said, I set popsicle sticks between the router sled and the back rail. And then I touch the tool, the router bit, to the material. And I rotated my platform so that it was even all the way along the workpiece.
So the
And then I
platform
took-
is parallel to the workpiece.
Parallel to the workpiece, yes.
Oh, okay, got it.
Yeah, Beal, one of the things Beal had is they have a pen, what they call a pen turning lathe, and does ornamenting, something like that. What they came up with, they'd had a bushing around the bit, and that's how you set the depth. I thought that, boy, that was a really cool idea. I mean, obviously this would have to be a pretty big bushing, but you know, if you only wanted that to be a 16th or an 1/8 or a 1/4 of an inch, you'd set that thing, and then you'd rub it across the outside, and the bit would only cut down that particular size.
Yeah, that was my problem. I couldn't find anything to make that bushing out of. So
My bushing is made out of a piece of nylon block, fits right on the end of the router. And it actually rides alongside whatever you're cutting the flute into. So it keeps it at the same depth.
Yeah. I
Well,
actually have.
Wouldn't you
Yeah,
have to keep something that tensions it? Let's say your curve is not straight. You know, you're doing cutting flutes in the side of a vase. Wouldn't you have to keep it tensioned towards into the piece then too?
Well, you can cut a board that is the shape of the highs and lows of that curve, and your router base follows the curves of that sacrificial board that you mount to your lathe bedway.
Right.
Right. Yeah, I've done that too. Okay, all right. All right,
either
cool.
that or the nose piece that we were talking about earlier, that does the same thing.
Yes, it
Yeah,
does.
well, like Cade was talking, you could have that piece, that sacrificial piece or a fence that you would guide along anyway. You're working with a straight edge right there. If you'd modify that sled to follow a sacrificial or a template, you can do whatever you want on the edge of that, because that's going to control it like it does
Yeah.
now.
Yeah, that's what Rick was talking about earlier.
And you
Yeah.
can set it so maybe it's deeper on one end and then it runs out at the other end. So the spire itself will taper from full size to just leaves the workpiece.
Yeah, you just set
Beautiful.
the sacrificial piece to follow the taper to get whatever depth you desire.
Well, then you can move it a little bit more so that it comes out of the taper.
Yeah,
Yeah.
Yep.
Possibilities are endless.
infinite
That's very
possibilities.
cool.
All right.
Very conceptual. Thanks, Rick.